we're now going to create a visual representation of the chi-squared distribution. So the way, and this is to the answer and support our result from the previous section that I showed you. So if we go into the probability calculator and we want to bring up not normal, but we want to change this to be chi-squared, and this is actually going to be 2 degrees of freedom for this question, and let's say we want it to go all the way to the end. Just put it in, say, as 100, so we get that result. Now these figures aren't relevant for what we're doing, but we can fix it up in the other window. So we're going to go and copy this into the graphics view, and then in the graphics view we get this. So this is our function, the gamma function for chi-square. So we need to just then think about how we're going to set this up. So we want to have 1% of our results appearing to the right hand side according to how this problem is laid out. So it means that chi-squared is going to have to be at 9.21, but I'll just bring this across. Whoops. We need to just rescale this basically, so, but it's not being very agreeable. Let me see, bring this across. Okay, so that's perhaps a little bit better. Alright, so we could take the integral of this, so take the integral of this function, and the function is f, and no, we don't want to take the integral. We want to get the inverse chi-squared. It's 2 degrees of freedom, and we want the probability to be 0.99 on the left hand side. So when we do that, we get a value of 9.21. So from 9.21 across to the right hand side, you have 1. You have 1% of values. So you could confirm that by going and doing the integral, but I'll just go and mark that point in. Say I'm going to call this the point n, which is equal to that point B appearing on there, so hit enter. Alright, so there's that point N. So again, a little hard to see it clearly, but what it's saying is that if you were to get the integral to the right of that, you would only get 1% of the result. So let's see if that's true. So the integral of the function, which is just f, and the starting value is that value b, and where does it go to? It goes all the way to infinity. So there's infinity, hit enter, and it calculates it for us. So now it's not really showing up that clearly at the moment. And what we could do is make it more solid, and that's the area there that represents 1%. So that's our rejection region of the null hypothesis. Now we had a value, the chi-squared value for this question was 6.956. So if I go and make another point with that, so m is equal to 6.956, hit enter, and then create a point big M, which is equal to m comma 0. There's that point, and you can see that that point actually lies outside of the critical region, so therefore you will accept the null hypothesis. So that's essentially what's going on with the question. So if I move this across to here, you can see that this has a value of 0.03, so that's the what we call the p-value. So you can work out some of these things in other ways as well, but Yeah, so that's just giving you a visualization of what's occurring with the problem.